Alright, testing 1, 2, 3. So today's going to be a bit of a special, because now I'm going to try to tutor once again the student I had yesterday, but hopefully with less technical difficulties. But until then, please bear with me while I get things ready. Okay. Okay, same board as last time. Cool. Alright, now we'll try the conference call and see if that works.
Hold on, it's not popping up for me.
Oh.
Let's try resending it. Oh, I see it. Hello? Hello?
Alright, testing 1, 2, 3.
Alright, yeah, no, I can hear you.
Okay, you can hear me, but I can't hear you. I hear you over the phone though. Do you know if your laptop has a microphone built in?
Yeah, my microphone's on. Let me try turning it off though.
Okay.
Alright, can you hear me now?
No. Wait. Try again?
Testing, testing, 1, 2, 3.
I only still hear you over the phone.
This
Okay. That's fine. I'm gonna hang up on the board conference call thing, so then we'll just use over the phone if that's okay. All right. Okay.
hello?
All right. Hello there.
Hey.
All right. So you're able to hear me?
Yeah, I can hear you.
Great. Okay. And have you tried using the touchscreen a bit more? How do you feel about that?
Alright. Hold on, let me actually. I would have drawn something else that was better, but I don't know where my drawing pen is.
That's totally fine.
It's easy to draw with a pen, huh? What's it called? I drew a guy.
Mm-hmm. Yeah.
That's cool.
Yeah, I see your guy.
Let me get my backpack with the assignments from yesterday.
Okay. Yeah, for sure. All right. Now there's a faint outline here, so I assume that we'll have to keep our drawing within this kind of area. All right.
Alright, I'm back. What happened? I got logged off.
Wait, it logged you off?
Yeah, I'm
Uh
loading back in right now, but
oh. Okay.
it's weird. Alright, I'm gonna go get a quick glass of water, and we'll get right to it.
Okay. Yeah.
Can you change the filter? Okay. Alright, let's get to it. Hello?
Yeah.
Alright, let me get out the paper we were doing yesterday.
Yeah. And I hope you don't mind if I zoom in a little bit.
You know, it's fine.
Last time, I think we're looking at this stuff, right?
The pencil in the right answer to you. Paper that turned into alright. But you know, there's a few questions on here, so what were you saying?
Yeah, last time we were looking for these new kind of symbols and new ways of writing multiplication and division.
Gotcha.
And it's that way the math can be more legible as it gets more advanced.
So, what question were we doing yesterday?
This one.
Yeah, the question that I couldn't figure. Yeah, that was the one. Okay. So, yeah, no, that's all it says.
Okay. Yeah, and that's totally fine. So just like how you might have an equation that just has this stuff together, where it has pluses and minuses, when you get into the more advanced math, they're going to change the division symbol. Instead of just having a division like this, where it's just like a line with the two dots on the top and the bottom, they're gonna actually have the numbers stacked on top of each other. And the reason why is because as like equations get bigger, it's more easier to read. So say for example, if you have like I don't know, like 1 plus 3, and then you have that divided by 4 minus 8, right?
Yeah.
Instead of having it look like that, where the symbols and it just gets longer and longer and longer and longer, by having it stacked for division, you could have 1 plus 3, and the whole thing is 4 minus 8. Like that. It's basically the same thing, but instead of needing all these extra parentheses and having everything like in a line, it has everything kind of separated, so then that way you can kind of sort it out easier. And then you could simplify it into something like 4 over negative 4. And it's still going to be just like over here, 4 divided by negative 4.
God.
Yeah. So for this equation right here, do you want to take a shot at it?
I guess. So what you said earlier, right, was this. Can I take a peek at what you wrote just now?
Yeah, of course.
So it's like it's basically I think it's paper. It's 30. I think I get it. Just a bit. So would it just be right over here, right?
Mm-hmm.
It's so would this be 3 plus 4? Not 3 plus 4, 3 plus 0?
Not quite, because there's no plus symbol in the middle like that. It would just be 30.
So, and then what happens down? Is it positive 30 or negative 30? I should ask that first.
Yeah, so with the number that you gave me, if it looks exactly like this, it can be rewritten as negative 30 divided by negative 6.
So, Mom, am I allowed to use a calculator? Okay. Mom said I'm allowed to do a calculator because I don't want it. I'm bad at math.
Okay.
So, negative 30 divided by negative 6. It would be 5. I'm allowed to use calculators. So it'd be positive 5.
Yeah.
How would we get to the positive though?
Yeah. So that is a great question. So negatives are kind of a funky number thing. So when you have like how do I put it? There's positives and negatives, and when you have a positive multiplied or divided by
the opposite of
another.
Yeah.
Yeah. If it's by positive, then it's still positive. If it's the opposite, or if they're not equal, then it becomes a negative. But then if it's two negatives multiplied or divided by a negative, then that becomes a positive. So when they're the same, it's positive. Even if it's negative, it becomes positive. Whereas if they're unequal, then it still remains a negative.
Oh yeah, quick question. How do I upload pictures of the stuff?
Yeah, so if you have the picture on your laptop, there should be an option on the top right with the 3 lines where you would be able to insert images. And you could choose from your device a file. Or if you copy it, like if you have something that you could copy or screenshot, you could copy and paste it onto here.
So do I have to paste the... Oh, choose file from my device. I see. I don't have the math online, so that sucks. And now... Is that a camera? I can't tell. Mom, does this laptop have a camera? Because I don't see it. So what you're gonna have to do is take a picture with your phone and email it to yourself and then open it up that way. You do that? I don't know. Let me think of that.
That could work. But at this point, I think the easier way might just be to draw it. As long as you draw it accurately, we can work with it.
Yeah. I wanted to... The reason why is... First of all, I want to get this work done, but also I wanted to show you some of the art that you're working on.
Okay.
Yeah, I was going to... I know. Okay, so what's next? Next would be negative... this is a bit confusing because it has a negative. Let me draw it actually. So let me find
Yeah, of course.
So it has... So it's like negative, then parentheses, then line, then 1, then 0, and then over -6, and then add a -2. Okay.
Ooh. Okay, and this whole thing is in like a big parentheses like this? With a negative on the outside?
Yeah.
Okay, got it. Alright, now before I go on to this one, I'm actually going to backtrack a little bit to the 30/6 just to kind of show you a little bit how it works too, okay? So,
And I can't see it. It was this.
yeah.
Alright.
Yeah, but I'm screening this way just so that we have a bit of space. Because I'm going to be doing it right there.
Okay.
So for the -30, now the way that numbers work is you could always like manipulate it, and you can always make it a bit weird. So, like here we have the number. I'm gonna take a separate example, 8, right?
Yeah.
And then 8 equals 4 plus 4, but it also equals 4 times 2, right?
Yeah.
And so when you know that, you can also get bigger numbers and you could break them up the same way. So this isn't the normal process, but just to kind of visualize it. So when you have -30 over -6 like this, it could also be made into something like -5 times 6 over -6. And the thing is with division, and the reason why they have them stacked here is not just because it looks cool, but also so it's easier to cancel things out. So the way that division works is that if you have something on top and on the bottom, you could cancel it like this, and then they both become 1. And then you could also cancel out the negatives, because they're on the same one on the bottom and then on the top, and so that's how we got the answer 5.
I'm a bit confused. Can you repeat that?
Yeah, of course.
Not bad.
No. It's. Thank you for letting me know you're confused and just not saying yeah. Because when you let me know that actually helps me kind of backtrack and explain properly. So for here we split the -30 into 5 times 6, right?
Uh-huh.
But it's still a negative, so we keep the negative on the outside. And the way that division can work is it could cancel things out. So let's say, for example, if you have how well do you know fractions?
Not the best.
Okay. All right. So a fraction would be something like do you know 1/2?
Yeah.
Okay, half of something, right?
Yeah.
Do you know how that'd be written as?
Yeah, it'd be a 1/2.
Yeah, perfect. So 1/2 would exactly be 1/2, right? Because it is 1 that is cut into 2 pieces. 1 divided by 2.
Yep.
And to have like 1 whole piece, it would be either 1/1, and that's just that equals 1, right?
Yep.
All right, but the weird thing about division again is that if you have 2 pieces of 2, so if you have 2 pieces of 2 things, that also equals 1 because the 2's, you have 2 of them. It's basically 2 halves. So it's if you have like 1/2 plus 1/2. The way this works is that because the numbers on the bottom are telling you how many pieces it's cut into, and this is 1. So I'm also going to visualize a little bit, okay?
Okay.
So let's say, for example, if 1 is a square and 1/2 is cut into triangles, right?
I get it now. So 1 is just the amount it would regularly be. So it's 1 that's cut into 2 pieces.
Yes, exactly.
So this would be the 1, and then it's cut into 2 pieces.
Yeah, so it's instead of having the other piece, it just has the 1 piece of the 2 pieces. So it has this one. And then this one has the other one of the 2 pieces.
Okay.
And that's why when you put them together, it becomes a little weird where then you don't add the bottom because that's how many pieces it's cut into. You only add the top. So it would actually be, it would look like this. It would look like 1 plus 1/2. Because they're still cut into 2 pieces. And then when you have 1 plus 1 into 2 pieces, that becomes 2/2. Sorry, it's getting a little crowded.
Yeah.
And then that 2/2 is when you smush these pieces together, and then it just becomes
I see.
1.
Uh-huh.
Yeah.
I get that.
Now, similarly, if you have something like this where it's 1/4, then that is 1 whole piece cut into a 4th. So it would look like this, and here's all the other missing pieces that aren't there. It only has this one. And then if you have 4/4, then that is 1 cut into 4 pieces. But because you have 1, 2, 3, 4, then it's technically 1. Does that make sense?
Go back a little bit.
Yeah, sure. So here we have 1/4. Just
Hey,
like...
Mom.
Huh?
Mom, can you turn off the TV real quick? I get distracted by it. Okay. Explain that again.
Yeah. So just like here when you had the 1/2, which is, 1 piece cut into 2, here is 1/4 where, the whole square, that would be 1, right?
Yeah.
And it's also 1/1 because there's 1 piece cut into 1 piece, so there's no real cuts on it.
Oh.
Yeah. Like that. And then for 1/4, that is 1 piece that's cut into 4 pieces, right?
Yeah.
But then if you have 4/4, then that is 4 pieces, 1, 2, 3, 4. And even though they're 4 little pieces, together they combine to equal 1.
I see.
Yes.
Okay.
So that's how fractions work, but this is also how division works too. Where if you have, I don't know if I could draw like 30 things cut into 6 pieces. But you know, if you imagine a big chunk, right? And this is like 30, because actually, let me start easier. Okay. So what if you have, if 4 pieces over 4, that equals 1, right?
Yeah.
So then if I have 5 over 4, how do you think that would look like? Or what do you think that could be, you know, simplified into?
It's 5 pieces, like one whole. That is. I don't.
Yeah, you're on the right track. Just write it down.
Again, so it's worth 5, right? So, let me. So the total of this would be 5, but we only cut it 4 times. Or am I missing something?
You're missing something, but you're getting there. You're closer than you were before. Remember, 1 is one of these 1/4 pieces. So if you have 5, you only have 1, 2, 3, 4, and then there'd just be an extra piece over here. That'd be 5. So as you were saying, it would be 1 whole piece. So 5 over 4 does equal 1, but then also equals 1/4 as well. It's 1 and 1/4.
Okay.
Because it has the whole chunk, which is the 1, and then the 1/4, which is the little piece over here.
I see. I get that.
Yeah. And so this is kind of to help visualize the division and the math that we're doing. So that way, you know, if the number on top is smaller than the number on bottom, it's going to be some kind of fraction. If the number on top is bigger, or over here, if the number on top is bigger than the number on bottom, then it's going to be more than 1, and probably a lot more than 1. But if they're exactly the same, then it just equals 1.
Yellow?
Yeah. And again, a way to simplify it is with this process of crossing things out, because if you have 2 pieces that are cut into 2, then the math equals that it just looks like this. So this is kind of a shortcut to division, where you can simplify things a bit easier. So if you have, let's say, 8 over 2, right? Can you try to solve that one?
8 over 2 is... So, it's 1 whole 8, right? And then, so, it would be... let me look at the other one real quick.
Yeah. Take your time.
So, we have... So, it would be... 8... let me... It would be 8 over... let me make sure I'm writing it properly. So it'd be... Actually... 1 over 2 with 7... Sorry if I'm wrong.
Okay. Can you explain to me how you got there? And it's okay. It's okay if you're wrong. I'm just trying to understand the process.
So if we take the whole number, right?
Mm-hmm.
So this is 8. So what's it called? We divide it into 2. So that would be the 2 down here. Right? And then, like you said before, we have the 7 left over, right?
Ah, okay. I see where you got confused. My apologies. I think I didn't explain that well, but that's okay. So the way this would work is we'd actually look back to we'd break it apart, right? Or you could break it apart. You could keep it as it is, but basically 8 also equals 4 plus 4. It also equals 2 plus 2 plus 2 plus 2, right? And so if we break it into those pieces, and again, this is a little, I might be overcomplicating this, but I'm hoping this will help understand. The 8 over 2 could also equal something like 2 plus 2 plus 2 plus 2 over 2, right? And then that could be broken into 2 over 2 plus 2 over 2 plus 2 over 2 plus 2 over 2. And the reason why is because it's, the number on the bottom tells you how many pieces you need to equal one whole piece. It's not the number on top. The number on top is the total number of pieces. So that's the total. And this is, and the bottom number is telling you how many pieces would equal 1.
Gotcha.
So if you have at least 2 over 2 pieces, then that equals 1. If you have 3 over 2, well, you only need at least 2. Whoops. Let me try to draw that better. If you have 3 over 2, then that equals at least 2 plus 1 over 2. And then that can be split into 2 plus, whoops, 1 over 2. And then this means that equals 1 and 1/2. Because you need at least 2 pieces to be 3. So if you have 8 over 2, then that means you have a whole bunch of 2s that equal 1 piece. And that equals 1 plus 1 plus 1 plus 1, which would equal 4. Again, this might be a bit much. Also the simple way is you could just also think of it as 8 divided by 2, like that, and then that would just be 4. If you happen to know your multiplication and division by heart. But I'm just trying to show you a visual way, so that way you can kind of understand fractions, because I imagine it's going to get more complicated as you go through.
Yeah.
Yeah. Okay. So yeah, it's not quite 7.5. It would the answer would be 4. So is that okay if I try another sample one?
Sure.
All right. Let's mix it up. Let's go for 9 over 3. Yeah. Where 9 is the total number of pieces, and 3 is how many pieces it takes to make one whole.
I see. So it takes 3 pieces to make 1 9.
No, it takes
Correct?
3 pieces to make 1. Because 3 over 3 would equal 1. If you have 3 pieces, of something that's broken into 3 parts, like here's the 3 parts, and you have 1, 2, and 3, then that equals 1 whole.
Gotcha.
But you have way more than just 3. You have 9. So how many pieces or whole pieces would you have when you have 9, but you only need 3 to make at least 1?
Do you mean at least 1 9 or just the number 1?
Ah, okay. So it wouldn't be 1 9. It would just be the number 1. You need 3 pieces because to make 1.
3 ones. No, that would make sense. So it takes 3 pieces to make 9. Or no? Am I confused?
A little confused. Again, it takes 3 pieces of thirds to make 1. Just like if we go back to halves, for this shape, right? If we imagine the box is 1, this equals 1, here's 1/2, here's 1/2, right?
Yeah.
And I think I'm getting it confused because I'm drawing the whole numbers there. This technically is 1/3, 1/3, 1/3. So 1/3, 1/3, 1/3 equals 1 if you have 3 of them. There we go. Yeah, I'm sorry I was drawing 1, 2s, and 3s. I should have done 1/3, 1/3, 1/3.
Oh. That makes a bit more sense. Okay, so,
So here, with 9, you're saying that you have 9 1/3s. And if I was to visualize it, it would look like this. So here's 1/3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
yeah.
So we have 9 1/3s, but if they're all squished together, that equals, for the total for whole pieces, 1, 2, 3.
Okay.
Because if you have 9 divided by 3, it equals 3.
Yeah. So would the overall answer be 3?
Yes.
I can get that. So it's just the top divided by the bottom.
Yeah. And again, I'm sorry if I overcomplicated it, but it's exactly that. The top divided by the bottom.
Okay, so let's go back to the original question.
Yeah, sure.
Where were we? It was 108. So, what was the parentheses and the minus symbol on the outside?
Yeah, sure. So I'm gonna copy this. I'm gonna put it in some place that's less squished.
Yeah.
There we go.
I see.
Okay. So with this, first you want to do what's inside the parentheses first, like PEMDAS. So try to do that part first.
So, let's see. Okay. Divided.
Actually, there's a trick to this too. Wait. Okay, wait. Are you using a calculator? Cause pause.
Yeah, I'm using a calculator.
All right, you could if you could pause that because there's actually an easy way to simplify this too.
Oh, I already entered it in, but
Ah, okay. So you probably already know. Um,
yeah,
so what's the answer?
30.
Yeah, and the way it works is that you could also look at, because again, it's like a negative 180 divided by negative 6, right?
Mhm.
But because of the way it looks on this side, you can kind of do a bit of a shortcut. You can kind of, when it comes to zeros, if the last digits are zeros, and this only works if it's like in the tens or the hundreds, you could kind of like
Mhm.
imagine it's not there, just for a second, right? It's still gonna be there, and you can only do it if that's the end, right? If it's like 1801,
I get it. I get it.
yeah,
Because 6 can only fit into 18. Yeah.
yeah, 3 times. So
Yeah, no,
then,
I get that.
so then,
And then you just add the 0 afterwards.
yeah, you just tack it right back on. Yeah. So
Smart.
yeah, so even though it looks like a big scary number, that's a neat little shortcut, just in case they don't let you use the calculator in class.
Yeah, no, depending on the questions and stuff, they have an entire, like, wall pouch full of calculators.
Oh my goodness. Oh, that's handy. Okay. Okay.
Yeah, so the teacher will be like, everyone grab your calculators, and then we all just go over to the back wall and then grab one.
Neat.
Yeah.
Yeah.
Alright, anyways, got a little sidetracked there. So, the answer would be 18.
30. Right?
Oh, 30.
Yeah.
My fault. I got confused.
That's totally fine.
Yeah, my fault.
No, that's okay. Alright, so then yeah, the negatives, they cancel against each other. The 6 divides into 18 3 times, so then you have the 3 on top, and this becomes 1. And then,
But still, what is this for in the parentheses?
yeah, so we keep that, right? We're holding on to that, because right now this transforms into 30, right?
I see.
Now, whenever you have this weird thing with the parentheses, and it has like a negative, or sometimes you might even have something like this, where it's the opposite, right?
Mm-hmm.
In either case, what's basically happening is that you're multiplying the inside number with an invisible 1 that has this charge to it. So if you have a negative 30 on the inside, and then there's a parentheses and a positive on the outside, then that becomes basically 1 times negative 30, and it just becomes minus 30, right? And even if you had something like this where it's, you know, minus 30, then you have negative 30 times negative 1, and that becomes 30. Or positive 30.
See.
But here, it's the opposite, where you have the negative on the outside and the 30 on the inside. So that'd be negative 1 times 30. And what would that be?
30? Like negative 1 times the... Oh, 0? Because it's a negative. Or... explain it to me.
Sure. So, with parentheses, it's just a tool to kind of tell you focus on this part first and then do the stuff on the outside, right?
Yeah.
That's basically all it is. And you could have any mix of number parentheses, so then that'd be like this one first, and then you do this one, and then you do the one on the outside, right? Now, when you multiply things, normally it would be, there'd be a symbol, right? So like a 2 times 2, or the new one that they're going to be doing is 2 times 2, right?
You know, we're already doing that.
Yeah, but then also if you do this, 2 parentheses 2, that also means multiply. It's a shortcut without having to write multiply inside of it.
I see.
Yeah. But when you just have the symbol on the outside, you know, it can be a little confusing, because you're thinking, well, what exactly am I multiplying? Well, you're multiplying that symbol and there's an invisible 1 there, because, I mean, you could multiply 1 to anything, right? So, like, 2 times 1 equals 2, right? So then you could
Yeah.
have, like, 2, 1, and that still equals 2. You could have 1, 2, that equals 2, stuff like that. But the thing about that 1 is that you could also, if you have a symbol attached to it, like a negative, then it changes the equation.
Mm-hmm.
So that becomes -2. But sometimes, as a shortcut, they wouldn't even write out the -1. They would just have it a negative like this, but that 1 is still there. And then it becomes, you know, -1 times 2 equals -2.
I see.
And so that's exactly what we have here, where we have basically the parentheses with a negative in front, but it's technically a -1 being multiplied to the 30.
Mm.
And so with that, what would the final answer be, you think?
Wait, what was the last part?
Yeah, sure. Okay. So, um, do you know that putting a number next to parentheses means multiplying it, right?
Yeah.
Okay, cool. And then if you just have the symbol next to a parentheses, like negative, then that also means to multiply the symbol into the number.
Uh-huh.
Yeah. And so just like here, we have negative being multiplied into the 2, and it becomes -2.
Mm-hmm.
You can apply that same logic right here with this equation. We have the negative.
So, is it -30?
Yeah.
Okay. Let me write that down. -30. There you go.
Okay.
Okay, next one.
Yeah. Yeah, I'm gonna move around so then we have more space.
Hold on. I wrote it under the wrong box. -30. Okay, next one. Let me write it down so it's then and then 3. Okay.
Wow, that got big real quick. Okay.
Yeah.
Well, how about you give it a shot? Just try to work it out and draw it out, explain it as you go along.
Is it like the last one we did? So, hold on.
Yeah, take your time.
So.
And remember, you can move the screen around to kind of look at what we did. I know it's a bit of a mess, but it's there if you want it.
Yeah. Are these two negatives, or are they? Is it -8 minus 10?
It looks to me like it's -8 minus 10. If they were two negatives, then they would have parentheses separating them each other. But just looking at it, it looks like as it is, just -8 minus 10.
So that would be so that cancels out to 2, right? +2.
Well, keep going.
So take this out. It's +2. And then it'd be 2 divided by 3. So that would only equal out to 1, right?
Not quite. So we're gonna leave this here, and we're gonna try a few other examples if that's okay.
Okay.
Alright.
Yeah.
So if we have 2 minus 5, what would that be?
2 minus 5, 3.
Okay. And what about 5 minus 2? What would that be?
It'd still be 3.
Aha! Alright, that's the trick. So not quite. So the first one is incorrect. Because what you have is you have alright, so the second one, right? You have 1, 2, 3, 4, 5. And you're minusing 2. And then you're left with 3, right?
Yeah.
But then for the top one, you only have 2, but you're minusing 1, 2, 3, 4, 5. And because there's nothing to take away, that's how you get negative 3. Yeah. So when you have a smaller number minusing a bigger number, it's a negative.
Oh, yeah, no, now I just remembered that. It took me a second, so, for an example, 3, let's see, minus, I don't know, 4
Uh-huh.
would equal -1.
Exactly. That's perfect, right? Hey, good job. All right, you got it. You got this. Excellent stuff. So,
Seems close.
yeah,
Where were
but also this is more tricky, and I'll get to that in a second.
Oh, and I can't find where we were at.
It's
Let
okay.
me zoom
I know where we're at.
in. Okay.
Yeah. All right. So then now let's try something a bit different. Where what if it's -5 minus 2? What would that equal?
-5 minus 2. -3. Right?
All right. But then what about -2 minus 5?
Would it be -7?
Okay. Now let's try. Now I'm gonna leave that there. One of these is incorrect, but hold on. Okay, what is 5 plus 2?
7?
And what is 2 plus 5?
Oh, wait. Did I get that wrong? No, I didn't. 2 plus 5, it's still 7 because it's a plus, not a minus, right?
Yeah. So when you're adding numbers, it's no matter which way they're facing, it's always being added together to make a bigger number, right?
Yeah.
Now the weird thing about negatives is that when you minus a negative number, just like you did here, this is correct, they add together. -2 minus 5 is -7. Similarly, when you have -5 minus 2, that's actually also -7.
Uh-huh.
Yeah, because you have, -2, and then you minus 5, and then that becomes 7. Same here, it's just in a different order. Just like when you add positive numbers, when you minus negative numbers, it becomes a greater negative number.
Uh-huh.
Yeah. So then going back to here, where we have -8 minus 10, what would that be?
Wait, go back a little bit.
Yeah, sure.
So,
Remember, adding positive numbers, it doesn't matter the order,
yeah.
you get a bigger number. And minusing negative numbers, it doesn't matter the order either. You'd still get a bigger negative number.
I thought the 10 was just a positive, though.
Ah, well, the way that you wrote it here is -8 minus 10.
So, would it just create a bigger negative then?
Yeah!
Okay, so it'd be negative 18, correct?
Yes.
Okay, so, negative... Let me, go to draw. There we go. Negative 18. Eh, and then... I'm drawing with the desktop pad.
Yeah, you're doing great. Well, remember, if you have a touch screen, you could use your finger with that too.
Oh, yeah. Hey, Mom, can we get a mouse one of these times? Okay. But... So now it's negative 18 and it's division, correct?
Yes.
So dividing... Let me do some quick math. I'm not going to use the calculator because I don't feel like it.
Yeah, that's good. Totally fine.
Negative 18 divided by 3, it would be... I want to say negative 4. Actually, no, negative 6.
Yeah, -6. Perfect.
I caught myself.
Yeah, that's excellent.
Alright, nice. Alright, so that question would answer to -6. Let me put that there. Give me a sec.
Yeah.
-6. There you go. Okay. Because since it's a negative up top and it's not both negative, then it just equal a negative, right?
Yes, exactly. Yeah, because the bottom's technically positive, so then, negative positive makes a negative. Perfect.
Yeah, no. Yeah. Alright, next question, and they only get harder. Isn't that fun?
Oh boy.
Let's see, let me find a good spot. This is a good spot right here. It's 3 on 3 on, I need to write smaller.
No, it's okay. You could write big. We could just zoom. Whoop. Sorry, I dropped the phone.
Rip. Minus parentheses negative 12 over 25 end parentheses.
Ooh. Okay, this is tricky. So now, when you have stuff like this, these are fractions, right? Or, I mean, again, they're division, but they're also technically fractions. And when you have a fraction like this, you can't actually mush them together because the bottom parts are different. They have to be the same, and that's the only way in which you can kind of combine them together.
Okay.
The reason being is say for example, if someone has like whatchamacallit, 1/2 plus 1/3, right? Seems easy enough. However, when you try to add them together, it's not like 1 plus 1, 2 plus 3, because then that gets you something like 1/5, which is actually smaller. Like you have 1/2 here, you have 1/3 here, right? And then all of a sudden you... Alright, let me try to draw it with the squares, so it can kind of be example.
Okay.
Alright, so you got 1/2 here, you got 1/3, which is like a weird triangle here, but then you have 1/5, which is like that, and that doesn't make sense.
Yeah, no, I'm confused.
Yeah.
Three.
So the way that you actually make it work is that you have to have both bottom parts have the same bottom number. And the easiest way to do it is to find the least common denominator, or the smallest number that they can both equal. So, so for this example, if you have 1 over 2, that can also be basically expanded into 3 over 6. Because if you multiply 2 and 3, that becomes 6. And then to match the 3 to match that... Oh, sorry. Okay. Let me try to draw this out a bit better. So you have 1/2. And then you know that 3 over 3 equals 1. And you can multiply anything to 1. So what you could do is for that 1/2, you could multiply it by 3 over 3. And that becomes 3 over 6. That's how I got that number. And again, you could also simplify it too. So if you have 3 over 6, that can also be simplified into 1/2.
I'm tired.
Okay. Yeah, I think this will be the last one. Because I do have to go soon.
Finish all the paperwork though? Did you finish? We're doing it question by question right now. How many questions do you have left? A lot. I'm tired of you not finishing the paperwork that needs to be turned in. After this, if you're that tired, there's more late. I don't know how to do a lot of these. I am paying attention. I don't know a lot of how to do a lot of
You still good?
Yeah.
Okay. Alright. So just to kind of keep going on this one really quick. So we want to have the same number on the bottom for both. So we can multiply 3 over 3 to the 2 to make it 3 over 6. And then for the 1 over 3, we can multiply it by 2 over 2. So then that could equal 2 over 6. So then this question of 1/2 plus 1/3 then becomes 3 over 6 plus 2 over 6. And that one works. Because then you could squish that, have it all over 6, 3 plus 2, and that would equal 5 over 6.
Yeah.
Okay. So for here, what we want is we want the bottom number here to equal the same bottom number over here. What's the simplest way to get them both equal?
You times them together. You multiply them, I mean.
Not quite. We're trying to multiply by something that makes them equal. So just like how I did with 3 over 3 over here.
Oh yeah, no.
Because it's 1.
What's it called? So what's the closest number that both 3 and 12 can multiply into, right?
Ah, no, it's the bottom numbers.
Oh, so right concept, wrong numbers.
Yes, that's totally fine.
So I would think it'd be 30, right? Well, not 30. The closest number. Well, 5 can times into 25 already, right?
Yeah, it can. So how do we get this 5 to become a 25? What do we multiply it? That's like something over something that has to be the same on top and bottom.
5?
Yeah. So you just you multiply it by 1, which is basically 5 over 5. Alright, so then your equation is going to kind of look like this. And I'm trying to do dotted lines because this is like kind of imaginary, but it still works.
Yeah.
So then what's 5 times 3?
5 times 3, 15.
Yeah, so they're gonna have 15, and then you already know 5 times 5 is 25.
Yeah.
So they're gonna have 15 over 25 minus negative 12 over 25. Alright, and then how does this negative go into here? What happens?
Which negative? This, so it would have to, I don't know.
Yeah, it's a bit tricky because they have the negative on top here with the 12. But basically, you know, negative 12 like this over 25 also equals, you know, negative 12 over 25. Because the whole thing's negative. Because if the top part's negative and the bottom part's positive, then the whole thing becomes negative. So then...
so the entire thing is just negative now. So we just put a negative symbol right here. No?
Yes. But also, again, that's just with it's in the parentheses, right?
Yeah.
So then we still have to figure out how do we get this negative into there, and what happens when we put it in there.
Yeah.
Because remember, there's that kind of invisible 1. So what's negative 1 times negative 12 over 25?
12 and 25.
Yeah! That becomes positive, right?
Oh, yeah, you're right.
So then this changes into 15 over 25, and because we multiplied the negative 1 into there, that pops the bubble. And it just becomes plus 12 over 25. Alright. And then what's next after this?
We just add them together, so the denominators stay the same, so 15... quick math. 15... blah, blah, blah... 27?
Yeah! 20...
so the answer is 27.
27 over 25. Yeah.
Yeah, 27 over 25.
Perfect.
Beautiful.
Alright, and I do have to head out, so I'm sorry I wasn't able to help you more, but hey, you did great. This was fantastic. And again, this page is here, so if you want to look at this stuff again or zoom out or mess with it, it's here for you, okay?
Okay.
Alright, and then I'll reach out again next week so we can keep going. Is that okay?
Ask him if we're gonna do Mondays and Tuesdays or just Tuesdays. Mom asked if we are gonna do Mondays and Tuesdays or just Tuesdays.
Just Tuesdays. Today was kind of an exception because I have the day off. But yeah, it would my only availability is Tuesdays. I'm sorry about that.
Okay.
Alright.
Alright, bye.
Alright, until next week, I hope you have a great time, and bye-bye.
Yeah. Bye, have a good night.
Good night. Ah, that was wonderful. How wonderfully productive. This was great. Dang, I'm really sad to end this, but I do have to go. I have another appointment. But yeah, for anyone that's coming by, again, this is tutoring. I try to do it janky because we're using the phone and also this stuff. But hey, it's legit. It's math. We got it. All right, until next time. Have a good night. But yeah, again, no, it's nearing the end. But anyone that came by and thought this was fun tutoring, insightful onto the style which I tutor, there you go. I hope you enjoyed it, and I guess I'll see y'all next week.